In this video, we'll continue our discussion of derivatives on vectored value functions, talking about a unit tangent vector. We found tangent vectors which describe the growth, right? Just like a tangent line did in two space. A unit tangent vector is going to do the same thing, except for it's a unit vector. So this would be a great way to describe direction without worrying about magnitude. Okay, so we're going to find a unit tangent vector and the point of tangency for that function at that time, or at that t. I guess we don't know if we're talking about time. So I need to find each part. I got to find r prime, so I'm going to do that. So let's identify x of t. X of t is 2/3 sine of t, which tells me x prime of t is then 2/3 cosine t. Y of t is equal to negative cosine t, which tells me y prime of t is going to be sine of t, because derivative of cosine is negative sine, cancels with that negative. Z of t, a 6, so the derivative of that, z prime of t, is equal to 0. So let's find our point of tangency. Actually, we can write that down since we're in the middle of that. R prime of t is equal to 2/3 cosine t, comma, sine t, 0. All right, they want the unit tangent vector and point of tangency at that point. What I could do right now is I could go ahead and try to find the magnitude of r prime, but since I already have to find it at a t, I'm going to go ahead and just plug t in and then find its magnitude. So r prime of, I'm going to go ahead and plug in 5 pi over 6. Okay, cosine of 5 pi over 6. 5 pi over 6 is a small angle right there. Cosine is our x, so it's negative rad 3 over 2 times 2/3. And then sine of that one is 1/2, positive direction, so it goes up. So this is equal to negative rad 3 over 3, 1/2, 0. So that is the vector at that point. What I said to do, instead of finding r prime of t magnitude, I'm going to go ahead and just find the magnitude of r prime of this actual value. So now I can just use the values that are in there, and they're just much easier to use than the expressions themselves. All right, so that ends up being the square root of, okay, the square cancels, and I get 3 over 9, which is going to be a 1/3 plus 1/4, and that's going to be a 7/12. And we can just leave it like that. So the tangent vector, t prime, the unit vector, it's always a unit, is going to be 1 over the square root of 7/12 times the vector negative rad 3, 3, 1/2, 0. We could simplify this. Square root of 12 over 7 times negative rad 3 over 3. I don't think this is going to make it prettier at all, so there's really no point to go through that. I would just maybe leave it there or the line above. And I did mess up. This is not the tangent vector of t. This is 5 pi over 6. If I wanted t, I was going to have to take the magnitude of that line, which is fine. It's just not going to be very pretty. The radical, everything's going to stay under the radical. They also ask for point of tangency. Point of tangency, how we go about that is we just plug the value in question into our function. So r prime of 5 pi over 6, but now we're looking at the original function. Let me zoom out here. So it's 2/3 sine t. 5 pi over 6 is 1/2. So we're going to get 1 over 3. Remember, it's a vector at first, and we'll change it into a point. Cosine of 5 pi over 6 is radical 3 over 2. So we get a negative radical 3 over 2. And then we get 6. So the point of tangency, I change it to a point, 1/3, negative rad 3 over 2, and 6. That is our point of tangency. We have found both. Just be very careful. I recommend doing this thing every time listed out like that. It's easy for me to check your work. It's easy for you to recheck your work and find mistakes. Just be as clear as possible.